I don't know.
So this one is going to be March 7th, which is the last lecture before the break. It will cover chapter 1 to 3. I will, similar to what I did before, I will send you the exact topics you need to study. Okay, for this one. Uh, okay, so guys, I already started to explain this chapter 3. In this chapter, I'm explaining how can we use the key maps. Yeah, sure.
Before the test, are we able to get our quizzes back so we can see what we know and don't?
Yeah. So because we graded, you already took the previous quizzes, okay, and the last quiz, I already give them to the lab T8. You got what I'm saying? So we distributed all the quizzes we have, okay? Except the last one, we didn't finish it, but all other quizzes with the TAs, okay? So in this chapter, I'm explaining how can we use key maps, okay, to simplify functions. And as I told you, this approach, usually we use the key maps because it is much easier than algebra manipulation. You will see it by yourself. You will see by yourself how this approach is much easier. Okay? I already explained to two variables, and honestly, usually we don't use maps for two variables because this is simple case. Usually we use the key maps for 3 variables and 4 variables. If you have more than 4 variables, okay, the maps becomes more complicated. That's why usually if you have more than 4 variables, and by the way, this is what we are gonna do in one lab. In this case, you need to use computer programs, okay? In one lab, you know the simulator digital you have, you can use this simulator to do simplification. Also, there are some online websites you can also use to simplify if it is more than 4 variables. So last time I started to explain the three variables. So for example, here we assume we have x, y, z, and then I told you last time this is the map. This is how the map looks like. Okay, so I made it very clear. This is the area of y. What do you mean by this is the area of y? What this means? It means if you look for all the main terms here, these are the main terms. Okay, if you look at all the main terms here, they have y. So you can see y, 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 y. Okay. And when I tell you this is the area of y, that means anything else is the area of y prime. So this is y prime here. So that's why you can see here in this area, all the main terms have y prime. Okay. Same thing. I told you this is x. This is the area of x here. Again, you can see all of them have x. Okay. And this is the x of x prime. So you can see x prime here everywhere. Same thing for z. This is the area of z, okay? Because you can see in these squares, all the main terms have z, as you see here. That means anything else other than this area should be z prime. So that's why this part here and this part should be z prime. Yes, that's why you can see here z prime and you can see here z prime. That's what I explained last time. Very, very important thing. Okay, very, very important thing. Be careful here. Okay, guys. Here I'm defining x, y, z. And x is the most significant bit, z is the least significant bit. So here at x, you have 0, 0, 0, 1, 1, 1. If this is the case, so this should be x. And this should be y, and this should be z. If this is the case, okay? That means in one problem, for example, I can make it like A, B, C. There is no problem. Whatever you have here, gonna be here. Whatever you have here, here. Whatever you have here is gonna be here. You understand what I'm saying? Okay, so I can trick you, or someone can trick you. I can change it. I can say ZYX. So So again, whatever you have here has to be here. Whatever you have here has to be here. Whatever you have here has to be here. I'm not gonna trick you in quizzes or anything, but just I wanna bring this one to your attention, okay? So here, in this case, the most significant one, I call it X, that's why this is X. If you call it something else, Z or whatever, it has to be, you have to change the map based on what you have here, okay? I wanna just bring this one to your attention, okay? So anyway, and based on that, we found that here, so how can you get the midterm with this one here? How can you get it? Okay, if you look here, guys, this square is in the area of x prime. That's why I'm putting x prime here. It is in the area of y prime. It is in the area of z prime. Because I'm gonna put z prime. Same, I'm gonna do the same thing for everyone here. For example, look at this one here. This one is the area of y, the area of z, because this is the area of y, the area of z, in the area of x prime. Is that okay? So that's how I can write all the midterms here. There is another way, by the way, as I explained when I explained midterms before, there is a way, if you have this term, you can get the number from the term. How? Anything that is prime, so this should be corresponding to 0. Anything that doesn't have prime should be corresponding to 1. So that's what I explained in midterms. So this one actually should be 0, 0, 0, which is equivalent to midterm 0. That's why this one is midterm 0. This one is equivalent to 0, 0, 1, which is number 1. This one here is equivalent to 0, 1, 1, which is number 3. Okay? And this one here is actually 0, 1, 0, which is equivalent to 2. Okay? So based on that, again, based on that, you can see here, guys, we have midterm 0, and then 1, and then not 2. It's not 0, 1, 2. It's 1, 0, 1, 3, 4. Sorry, 0, 1, 3, 2. Okay? 4, 5, 7, 6. Why we did this switch? Okay, I did this switch so that whatever you have here, I did this switch so that this block or this part becomes the area of Z. Okay, that's why it's switching. Okay, but anyway. Okay, guys, any questions? Okay. Any exams in anything, I will give you this map. Okay, I will give you this map. So now, as similar to what I did in case of two variable, we are going to do two steps. The first step, whatever is the function you have here, you have to map, you have to represent this function here, you have to map it here. Okay, this is the first step. Step number two, once you do that, you need to look for groups to do simplification as I explained before. So for example, in this case, we need to look for ones here. So here, that's why here M1, so we have M1, M4, M5, M7. So this location, I know M1 is here, I know M4 is here, I know M5 is here, I know M7 is here, I'm gonna put ones. This is how we can map it. Is that okay? So again, as I said before, I can give you the function in the format of a truth table. I can give you the function in the format of sum of product this way. Okay, midterms. So I give you the midterms here. So you already know from what I explained in this course. If I define the function this way, that means these are the location of ones. So very simple, just to put ones in 0, in 2, and in 6. Is that okay? I can also give you the function in the format of max terms. So the same function here is going to have 1, okay, 1 and 3, 4, 5, and 7. So these are the location of zeros. Is that okay? Any questions? We have one more here. Yeah, one more here, guys. Look here. I can give you the function in the format of an equation this way. And then what I'm going to teach right now is, if I give you the function in the format of equation like this way, how can you map into 1 and 0 here? How can you do that? Okay. So let's see here. Let's start with the first one here. For example, I'm going to take this one first. X prime YZ. So any squares in the intersection of the area of X prime and the area of Y, the area of Z, you have to put ones. So where is What is here x prime? X prime is this area here. This is x prime, all this area. Okay. What is y? This is y. This is x prime. Okay. What is z? This is z here. Okay. What is the intersection between the three? Only this one. Only one. One is square. Okay. So that's why this is square, I'm gonna put one. Okay. Same thing. Same thing. Let's, for example, look at this one here. This term. Okay. Xy prime. So again, all squares in the intersection of the area x and the area of y prime should have ones. Okay. So this is y prime is here and x is here. So what is the intersection? So actually the intersection is this two here. Okay. I think this is, I'm sorry, I will correct this one. I think I didn't get x prime. That's why I put it here. Okay. So I will correct it. Okay. So please correct this one. It's x prime. Okay. So here x prime, y prime. So this is the area of x prime. This is the area of y prime. So it should give you these two ones here. Okay. Okay. So what about the last one here? The last one here is x. So that means this is the area of x. We have to put 1, 1, 1, 1 in this area. Is that okay? So again, what I'm teaching here, guys, if I give you equation in this format, how can you map ones and zeros here? Okay. So there is a very important thing you can learn here, guys. Very important thing. Okay. What you can learn here? I can learn when the term has 3 variables. So this is equivalent to only one cell. When the term has 2 variables, this is equivalent to two cells. When the term has only 1 variable, this is equivalent to 4 cells or 4 squares. Is that okay? Is that always? Yes, always. Okay. So for example, instead of x, I can make it y. In this case, this is y. This is the area of y. It's 4 squares. Okay. Instead of x, I can make it x prime. So this should give you this. It's still 4, right? And if I can make this one, this variable z, so actually it's gonna become this area. Okay. If I make it z prime, so it's gonna be this area and this area. So always, this is how can you in quizzes in the exam. This is how can you check if you made mistake or not. Very simple. If you have here, if the variable you have has 3 terms, so this is equivalent to only 1 cell. Okay. If it is 2 terms, so this is equivalent to 2 cells or 2 squares. If it is only 1 variable, whatever this variable is, it can be x, it can be y, it can be z, it can be x prime, y prime, z prime. As long as it's only 1 variable, so this should be equivalent to 4 squares. Any questions? Good. And then last time also I started to explain the idea of adjacent or neighbors. Okay. Again, nothing is new. This is similar to what I did in case of 2 variables. Okay. Why we need to know the neighbors? Because when I make groups, I need to know because groups should have neighbors. Okay. So I need to know who can be in one group and who cannot be in groups. Okay. Because they are not neighbors. Okay. So only groups I can put them in groups. Okay. So this is how I do simplification. So let's see. So before I start here, in case of 3 variables, every cell has 3 neighbors. Any cell, any square has 3 neighbors. Okay. When I go for 4 variables, almost everything is the same, but there are some very few changes. Like for example, every cell has 4 neighbors instead of 3. Okay. So let's for example look at here again. What is the definition of neighbor? This is similar to what I explained in case of 2 variables. Okay. So neighbor, 2 cells are neighbors if they are different in only 1 variable. You got what I'm saying? Okay. That's why here, if you look, let's start with this one. I want to look for the neighbors of M1. The neighbors of M1, again, I'm gonna say every square has 3 neighbors. Okay, so this one here we have vertical neighbors. This one and this one are neighbors. So this is neighbor, neighbor, and also these two also neighbors. Okay. Again, the rule I'm using is, you can see here, if you compare this one with this one, you can see there is only change in one variable. Same thing here, same thing here. Okay. Diagonal cannot be neighbors. Okay. So the neighbors of M1 are actually this one, and this one. Makes sense? Okay, who are the neighbors of M0? Okay, the direct vertical and horizontal neighbors, and also the other one. That's why I'm saying you can see this map as it is ruled when you rule the map this way. So when you rule this map, so this one and this one becomes direct neighbors. Okay. Again, but this someone can say, look, how can you convince me these are neighbors? Okay. Again, we have a rule. The rule is they have to be different only in one variable. So if you look here, if you compare here, this one has x prime, this one has x prime, this one has y prime, this y. So y is different, but only the z prime. So only y is different. That's why this one has to be a neighbor. This one. That's why you have to see it like it's ruled. Okay. When you rule it, this one will be next to this one. Okay. So let's see this one. For example, same thing for M2. Who are the neighbors of M2? Vertical, horizontal, and the other when you rule it back. M3, again, every square has 3 neighbors. M3, these are the neighbors of M3. Okay. What this means? It means if you have here 1, 1, 1, 1, 1. Okay. I can't combine these two together in one group because they are not neighbors. But I can do that. I can combine these two together, or I can combine these two together, and I can combine, as I'm going to explain. I'm just explaining what is the importance, why it's important to know the neighbors. Okay. Same thing here. Who are the neighbors of this same M4? This one here, and also this one. That okay? This one is not a neighbor to this one. It's not. Okay. Very important to know who are the neighbors, because if you don't know it, you are gonna make the groups wrong, and after that everything is wrong. Okay? Same thing for M5. M5 here. Who are the neighbor of M5? Vertical, horizontal neighbor. Okay. Same thing here for M6. So it has this one, and also this one. M7. This one here, this one here, this one here. Neighbors. Okay. Yeah, these are not any diagonal, are not neighbors. This because they are not direct neighbors. There is someone here in the middle. This can't be neighbor. And again, it's very simple. You can check. You can check between these two. You will find there are more than one difference. So here this one has z prime. So z is different. Y is different. So there are two differences, not one. Okay, very simple. Now let's talk about grouping. Okay, because so the main point here, guys, is I'm gonna go back to the very important example I have here. Okay, guys. As I explained, in case of two variables, the way we do simplification is you try to make groups. Okay, and the condition is you have to cover all ones. You must cover all ones. Okay, if you cover all the ones in groups, you have correct the function, but it may not be the most simplified. To make it the most simplified, number one, you need to minimize the number of groups. Okay, you need to maximize the size of the groups, simply because every group, for example, in this example here, guys, I have 3 groups here. Okay, so this is one group, and we have here one group. So I have 3 groups. Every group is equivalent to one term. So the number of terms you are going to have in the equation equal to the number of groups. That's why to calculate the most simplified function, you need to minimize the number of groups. But you need to cover all ones as well. You must cover all ones. Okay? If you forget only one, you are going to get a wrong function. You need to cover all ones. Okay? The other thing is the size of the groups should be, you maximize the size of the groups. Why? You can see here. Because if I can make a group that has only one, this group has 3 variables. So if you make a group of 2, so this one has 2 variables. If you make group of 4, it's gonna have only 1 variable. Okay, so when you maximize the size of the groups, actually you are gonna reduce the number of variables in the terms. You got what I'm saying? So again, and this is the definition of simplified function. So simplified function means two things. You need to reduce the number of terms, and also you need to reduce you need to minimize the number of variables in terms. Okay? And also, there is also something important here you need to learn, because this also can protect you from making mistakes. Look here, guys. If my group is only one variable, like this one, like this case. So in this case, the term you will calculate should have if your group has only one square, so the term you are gonna calculate should have three variables. Okay? If the group you are gonna calculate has two ones together, the term you are gonna calculate has two variables. Okay? So if you don't do that in quizzes and exam, for sure it's wrong. You got what I'm saying? The group you have for 4, any 4 should have only one value. Is that okay? So always. One more thing, guys. Here you can make group of ones. You can make groups of two. You can make group of 4. So any four neighboring ones, I can take them together. Any 2, I can take them together. Any 1, if it is necessary, you can take it. Okay. However, it's not allowed to make groups of anything else. So it's not allowed to make groups of 3. 3 don't make groups. It's not allowed to make 5, 6, or 7. You got what I'm saying? For sure, if it is 8, so that means all of them is one group. And this happens when the function equal to 0, when the function equal to 1. So all of them are zeros, or all of them ones. Okay, anyway. So for all of them ones. But anyway, this is a very extreme case. So usually the groups I have to make should be groups of ones, only 1 squares, or 2 or 4 squares. Is that okay? One more thing, similar to what I explained, as you will see in details right now, similar to what I explained in case of 2 variables. Okay, just give me a second. In case of 2 variables, the ones can share, some ones can share groups, or can be in more than one group if this can help you to make groups bigger. So in this case, for sure I will give you more details. So in this case here, and this is not the most, this is a correct function, but it's not the most simplified. You know why? Simply because I can take these 2 together as one group. I can make it this way. Okay. So by this way, this one shared. Yes, you can share. So this one can be shared between 2 groups, as you will see for sure in details. This is also not the most simplified, because instead of taking these 2, only 2, I would, as you will see in the mini example I have, I can make it 4. 4 better than 2. You got what I'm saying? And by this way, these 2 ones are shared between 2 groups. This is totally fine. Okay. So if you want to calculate the most simplified version for this one, so actually, yeah, this 4 is too good. 4 is good. So here I can't make bigger than this one. I can take these 2 as one group, and for this one I can make another 4 here. So 4, 4, 4. This will be the most. Anyway, I will explain in details now, but because this one is simplified. What I did here, I just represented the function here. Okay, but I'm going to give you more details how can you make groups. Okay, but for now I'm telling you, when you make groups, number 1, the groups can have 1 square, it can have 2 squares, or it can be 4. No, you cannot make groups of any other numbers. It can be 5, it can be 3, and so on. The second thing also I explained, some ones can share groups. Okay, for example, this I can make groups this way and groups this way. Okay, so this one is shared. Yes, this can happen. Okay, but for sure, if you make a subset, so if you take this one as a group and this one as well as a group, you know what's going to happen if you make something like that? This is sharing. So this one are shared. No, this is a subset. So here, actually, you are going to have a redundant term. So this one will be a redundant term. So this is not the most simplified, because this is completely different. Anyway, I will give you more details, but for now, so here I can take this one as one group. I can take this one as, for example, as one group. This is okay, this is okay. Why? This one here is shared between these two, okay? However, if you take subset, something like that, now you are gonna have two terms. This is one term, and this is subset is one term, okay? So, and you don't need, because this one should be enough, that this one should be enough, because already you covered all of them. So why you cover them again? Okay, but this is completely different from doing something like that. Because the reason, yeah, this one is sure, but here, because I have another one here, I want to take it in the groups. This is okay. But when you subset, you are going to create a redundant term. Okay, so yeah, because every group is going to be one term. You have questions? You have questions?
So when you make groups, like to say if you were going to make a group of 4, do they all have to be in a line, or do they all just have to be connected? Like, could you make M1, M0, M1,
Yes.
M5, and M7?
I'm gonna give you more details for now, but the answer, yes, they can be. For example, I can make a group this way, 4 this way, as long as they are neighbors. For example, I can take this 4 here, I can take this 4 here. Not only that, I can take this 4, this, and because they are neighbors. If you rule it, these are become neighbors. I'm gonna give you more details. Okay, so don't. Yeah. So here, guys, I'm talking about groups. Groups can be only one. So in this case, this guy doesn't have any neighbors that once. So the best thing I can do here, I'm gonna take this one alone in one group, because it doesn't have neighbors. So even his other one is 0, it's not 1. It doesn't have neighbors. So I can make it bigger than that. I don't have any other option. So in this case, I'm gonna take this one alone. Here, same thing. I'm gonna take this one alone. And when I take this one alone, so actually you are gonna have a term. You are gonna have a term that has 3 variables. Okay, and this is for sure the maximum, because so now this one has all the variables I have. Is that okay? Yeah, I don't have another option. I wish if I can, but I don't, because there is no neighbors to this one. Okay. Okay, let's look, for example, in this case, group of 2. Okay, so you can see here, I can take these 2 together this way, and in this case, I'm gonna have the term is gonna have two variables. How can you get these 2 variables? Very simple. So these two together are in the area of y. So I'm gonna take y. Okay. When I say 2 variables, that means you need to delete 1 variable. You need to omit one variable, because total we have 3. When I say 2, that means we need to remove 1. Okay. Which one I have to remove? I'm gonna tell you now. So this group, it is in y. It is in z prime. Y is z prime. But here, if you look at x, half of it in x, and the other half in x prime, because this is x, area of x is the area of x prime. So x will be omitted. So the variable you have to remove is the variable that this group is not located in this variable. This is the one I have to do. Before I take your question, let's take, for example, this group here as an example. I already know, because this one has two squares. So the term here has to have 2 variables. Okay. How can you get these variables? Okay, let's look at x. So this group is located in the area of x prime. Okay, I'm going to take x prime. Let's look at y. So these 2 are located in the area of y prime. Yeah. But if you look at z, this one in z, this one in z prime. So I have to remove z. Makes sense? Yes. You have a question?
Yeah, the one he was mentioning before, I don't think he knew, because he was saying, I think, 0, 1, 5, and 7. So it's like a Z almost.
0, 1,
5, 7,
0, 1, 5, 7. So you have 1 here, 1 here, 1 here, and 1 here.
Yeah, he's saying to group all those together.
No, you can't. You can't, because they are not neighbors. Okay, you can. So here, in this case, I'm going to take these 2 together. I'm going to take these 2 together this way. Okay, because I can't group them. I can group if they are neighbors this way. Okay, or if they are neighbors this way, or for example, if they are this way, or if they are this way, neighbors. This one here and this one are neighbors as well. Because if you rule it, I'm going to do neighbors. Anything else, for example, yeah, if you have 1, 1, 1 this way, there is no group like something like that, okay? Yeah, so here, let's see, for example, yeah, I have too many examples, so don't worry. Gradually, everything will be very clear. Same thing here, guys. If I take these two as one group here, that means this term has to be, should have two variables. Okay, so I have to delete one. So this group it is in Y, it is in Z, but I have to remove X because this one is in X, this one is in X prime. And let me say it in a different way. This group actually is in the intersection of Y and Z. So if you see, this is the intersection of Y, this is the intersection of Z, okay? So they are located in the intersection of Y and Z. You got what I'm saying? Same thing here, X and Z, okay? So X and Z here, so here, again, these two are in X. So I'm gonna take X, they also are in Z, okay? But if you look at Y, this one is in Y, this one is in Y prime. So I'm gonna delete Y, okay? Also, you can see if I make the intersection between Z and between X, I'm gonna get these two together, okay? Same thing here, X prime Y, okay? So I can group these two together. So both of them are in X prime, and both of them are in Y, okay? So yeah, now I'm going to talk about 4 variables. So maybe you have 4 variables this way. You already know you know that in case of four squares, I should have only 1 variable. Okay. So and in this case, all the one should occupy the area of 1 variable. Okay, so that's why you can see here all these ones are in Y, so it should be only 1. They are taking the area of Y. Here, all the ones are in the area of X. Okay, all ones here and here together, this here and here are in the area of Z prime. You got what I'm saying? But if you take, maybe regarding your question, if I take something like, I have here 1, 1, 1, if I want to take something like that, okay, if you want to take something like that, you are not going to find any intersections that give you this one. Okay, so you can't find it. You can't find a region that give you. Anyway, yeah. So here I'm explaining wrong groups. When groups are wrong, for sure, as I told you, number 1, if they are not neighbors. Number 2, if you have any other group other than this number. So if I make group of 3 is wrong, group of 3 is wrong. If I make group of 5, 6, or 7, they are wrong. Okay. Only groups are allowed are 1, 2, and 4. Okay. For sure, I told you 8 equals you keep everything. Okay. So anyway, so if you make a group this way, this is wrong. This cannot be 1 group. Instead, what you have to do is you can take these two together as 1 group. Okay, to get the most simplified. And then I can take these two together in 1 group. By this way, I can make 1 group here and 1 group here. And this one is going to be shared. That's okay. Someone else can only take this one as a group this way. So I can make 2 groups. This is 1 group and 1 group. Okay? The rule is as long as you cover all ones, it's a correct function. This function is correct. But it is not the most simplified. Why? Because I can make bigger groups this way. Okay, you will see it now. Yeah, that's what I'm saying here. So I can take if I take this one like 1 group and take this one alone, it's correct, but it's not some. Okay, I can't make group of 6. Okay, this is wrong. Okay, the best way I can do it here, I can take this 4 as 1 group. Okay, you can take these 2 together as 1 group. But again, this is correct, but not the most simplified. Why is not the most simplified? Because I can make 4. Instead of 2, I can make it 4. You got what I'm saying? So yeah, this is the most simplified. I can't make better than that. 4 and 4. Okay, but if you take these 2 here, okay, it's not the most simple. It's correct, but it's not the most simplified. Yeah, for sure, I can't take these two as a group because they are not neighbors. So in this specific case, I don't have any option. So I have to take them one and one. Okay, I can't make better than that. Okay. So here I'm explaining how can you decide the groups? How can you make the groups? I will tell you the summary. The summary, we have something we call it prime implicant. Okay. So what this means? It means implicant here means like a prime group, something like that. So what this one it means? It means this one it means the biggest group you can make. Okay, that's the meaning of it. Okay? So for example, for example, if I take this one alone, this is not a prime implicant. Okay, it's not prime implicant. Why? Because I have a better option. I can take it to the neighbor so that I can make a bigger group. So the bigger group is prime. So just making the definition. So if you have here one, okay, I can for sure I can take this one like one group, or I can take this one a group. Okay, so this one I'm gonna call it prime implicant because this is the biggest one I can make, but this one is not prime because there's a better option here. Okay. One more thing. So here, number one, if you have in your function, if you have only one implicant which is not prime, 100% your function is not the most simplified. So here I divide groups into two different groups. One I call it prime and one I call it not prime. So prime means like here the biggest possible groups here. Okay. So for example, in this specific example, this is prime, but if I take this one here, this is not prime. Okay. So that means any simplified function should have all the groups that in the simplified function should be prime groups. If you have only one that's not prime, your function 100% is not the most simplified. Okay? Even prime functions, prime groups, I'm gonna divide them into two types: essential and non-essential. You can tell from the English name. Essential means, for example, look here, guys. What it means essential? Essential means you must take this group. You must take this group. This group must be in the function because you don't have any other option. Okay? For example, let me give you an example. In this case, so first of all, tell me when you understand what prime means. Prime group, what it means. Prime groups, it means the biggest group you can make. Okay, that's the meaning of prime group. When the prime group becomes essential, when the ones in the group, at least there is one of them that does not belong to any other groups. So you must, to cover this one, I must take this group. You know, that's why I call it essential. So here we call a group, we call it essential group. Essential means you have to put it in the function. If there is at least one here in this group that does not belong to any other groups, you don't have any other option. You must take this one. Okay. Otherwise, it becomes non-essential. Okay? So usually, what we do, number one, you have to look for the essential. After you find the essential, first of all, you need to find the all prime groups you have, and then number two, you have to take all essential. For the non-essential ones, now I can have different variation. So I can have different variation to cover all ones because I need to cover all ones. Okay. That is why, as you will see in the example I'm going to explain right now, there is no one format for the simplified function. That means I can have two simplified functions that are equal. So the word is the minimum of simplified function. Yes, I can have more than one expression, more than one valid solutions. You got what I'm saying? Why? But all the solutions should have the essential groups. So the essential group will be appearing all of them. Okay. But when I take the non-essential groups to cover all ones, okay? So now I'm gonna take this group, but the other one's gonna take another group. You got what I'm saying? So that's why, as you will see in the example I'm gonna explain here, guys, simplified function It doesn't mean it's unique solution. No, I can have multiple solutions, as you will see in the example I'm going to explain. All of them are simplified, so you can have more than one. Yes. So here in this example, yeah. So for example, let me put here, for example, 1, and put here 1. Yeah. So for example, let me make another group this way. Is this group essential? Yes, it's essential because the only way to cover this one is to take this group. I don't have any other option. So essential. So even if you have multiple solutions, all the solution will take this group. There is no other option for this one to cover this one. Okay. Same thing here to cover this one. So I have here this one is essential because there is. But for example, if you have for example another solution this way. So now if you look at this group here and this group, okay. So for example, I'm just giving some example here. Yeah. So I can take or here. You will see, I'm going to give you some examples, but for example, just an example, if you forget. So for example, if this one, I can take it this way, or I can take it this way, for example. Okay, so anyway, so I'm going to show the example, but let me summarize what I said here, guys. What I said, number one, before I take examples, number one, I need to cover all ones. This number one. Number two, I need to minimize number of groups. I need to maximize the size of groups. Okay. Also, groups can be prime or not prime. Okay. Prime means the maximum group. Okay. Prime can be essential or non-essential. Essential means you have to take it. Non-essential means you have multiple options. I can take this group or this group. I have multiple options. Okay. And if you have multiple solutions, as you will see, for example, I can have multiple solutions. All the solutions are correct. All of them are the most simplified. You will find all of them have the essential one. Because essential means you have only one option. To cover this one, you have only one option. Anyway, so you will see in examples now. So let's I have how many examples? I know it's too crazy. So I put how many? 12, 14, 16. So you have 14 examples. You have to, because I think the best way to understand this topic is just by looking at examples. Okay. Okay, let's have this example here one by one. So for example, here, guys, number one, I'm going to give you this truth table. Number one, you have to map the truth table here, and then after that, you need to do groups. So here you can find here, I have one here and one here, M2 and M6. So I'm going to go to M2 and M6, both 1 and 1. Is that okay? So so here actually, I have two min terms, as you see here. I have two min terms, M2 and M6. As I explained in chapter 2, I can define this function. This function should be equal to M2 or M6, the two min terms. This is the first min term, this is the second min term, using SOP, sum of product, okay? For sure, this is not the most simplified one. Now, if I want to simplify this function, yeah, so here I have only two ones. I need to cover only two ones. So I can take these two ones together this way, make only one group. Okay. So what is this group? This group is the area of Y, the area of Z prime. That's it. I am done. Okay. Just I want to link what I did here with what I did in chapter 2. What I did in chapter 2, I told you any function is gonna be min term. Is the OR of two min terms. These are the two min terms. Is that okay? If I do algebra manipulation, I will get the same result. Okay, for sure. I don't need to double the work. So yeah. So anyway, so you can see this much easier, very easy. So let's see example number 2. In example number 2, guys, I have here, I'm telling you the function is you have ones in 0 to 6. So here in 0, I'm gonna put 1. In 2 and 6, I'm gonna put 1 and 1. So one solution, I'm gonna make one group here, and then I'm gonna make here one group. Okay, and because this is only one, you have only one square, so this one should be a term. Because you have two groups, I should have two terms, and because this one is only one square, so this term should have 3 variables, and this one, because it's 2 squares, should have 2 variables this way. Okay, so how can you get this variable? Very easy. If you look at x, I already know the term should have x, y, z. Okay? If you look at x, this one is located in x prime, so I'm gonna put x prime. This one is located in y prime, in the area of y prime. This one is located in z prime. Okay, so this is the first step. I'm gonna take these two together, and when I take these two together, these two one group. So this is I know this. I need only two variables, so I have to delete one variable. You will see. So this one it is in the area of y. It is in the area of z prime, but for sure I have to delete x because this one is x, this one is x prime. So y z prime. So if you see here, the intersection of y and the intersection of z prime is going to give you these two together. So this is the solution. Okay. As long as you cover all ones, this is correct solution. But is this solution the most simplified one? Yes or no? No. Why? Can you minimize the number of groups? No, I can't. But I can make this group bigger. How can you make this group bigger? I can take it with its neighbor. So this one here actually has a neighbor here. So by this way, this one can share. This one is going to be shared between two groups. This is correct. It's okay. It's allowed. Okay. So instead of taking this one alone, no, I'm going to take this one with its neighbor. Okay. So still I'm going to have two terms. However, the simplification I did here, instead of having this term that has three variables, I'm going to have one term here that has only two variables. Make sense? Okay. Let's look at this case here, guys. In this example, I have one here, one here, one here, one here. Okay. So here someone can make something like that. I can make a group here, one and one, like they are neighbor. I can make them a group. I can make this one also as a group, and I make this one as a group. By this way, I have three groups. I can make three terms, as you see here. So this is three terms. What's wrong here? Again, this function is correct. I can't say wrong. This function is correct, but this is not the most simplified. You know why? Why? Yeah, because this one's already covered in this group. I created a redundant group. So I need to delete this group. Okay? This group is not because already I want to cover all the ones, okay, in the smallest number of groups possible. Okay. So actually here when I created a group here, this group is redundant because these two, one and one already covered in groups. You are going to cover them again. Okay. Big difference between what I did here and between what I did here. Big difference. What I did here, guys, is in order to cover this one in big group, I have to take this one, which is already in a group. Big difference between this case and between introducing a new group you don't need. You understand what I'm saying? You know, if the one is here, yes, I would make something like this. This one is okay. Okay? But here, big difference between what I did here. Yes, I can share this one if this can help me to create a big group. But here, yes, I created a group. I don't need this group, right? I just made the group bigger. You understand what I'm saying here? So anyway, so here I created a redundant term. So it would be, this is one solution, it can be this one, okay? Now let's look at example number 4. So here I'm telling you the ones are at 4, 5, 6. So here I'm gonna put 4, 5, 6. I'm gonna put here ones. Again, you can make solutions this way. I can take these two together. I can take this one alone. By this way, I'm gonna have two terms. One term that has two variables. One term that has three variables. Okay. Anyone is still confused when you make a group? How can you get the variables here? Is that difficult? You can see again. You already know this one. I need two variables, okay, for this one. So this one already in the area of x, okay? So it is in the area of y prime. But I'm gonna cancel z. Why? Because this one in z, this one in z prime, so I'm gonna cancel. Even if you look here, just to make it, if you see, what is the intersection between area x and area y prime, you will find these two. These two are located in the intersection of x and y, okay? Yes, you can make it this way, guys. But again, this is correct function. This function should give you correct result, but this is not the most simplified function. Why? Because I can, instead of making group of one, okay, this is not prime. By the way, if you want to link with the term I used before, prime. This is not prime. Why this one is not prime? Because I would use it this way. This is prime. Okay? Prime means the maximum possible group. So, okay, so in this case, this one is simplified. This one is not more simplified than this one. Any questions? Okay. Question number 5. Here in number 5, guys, I can give you the equation in 3 different ways. All of them are any one of them should be okay. So here I can tell you the function here is the midterms are 1, 3, and 5. So you should go to location 1, 3, and 5. You put once 1, 3, and 5, and put once. Or I can give you the function this way. These are the location of zeros. Okay, so you have to go to location 0, 2, 4, 6, 7, put zeros, and so on. Other location should put ones. Okay, or I can give you the function this way. You already know. Be careful. You already know if this is 3 variables, that means it's only 1 square. You already know this 1 square. You already know this 1 square because it's 3 variables. So this is actually, if you see the intersection of x prime, y prime, and z, you will get 1 square. If you go to the intersection of x prime, y, and z, you will get 1 square. Okay, let's look at the intersection x and y. So this is y, this is x, okay, and then x and y. Sorry, this is the intersection of x and y prime. This is y prime, and z. Yeah, this is z. So if you see the intersection between all of them, should give you this one. Okay. This is one way to do it. There is another way. As I told you before, if you have a term like this one, you can get the midterm out of it. For example, this one actually is 0, 0, 1, which is number 1. This one actually is 0, 1, 1, which is number 3. This one actually is 1, 0, 1, which is number 5. Okay, this is another one. Anyway, okay. So if you have, so here I just located the ones this way. So yes, I can make one group this way, I can make one group this way. This is the best I can do. So I can make 2 groups this way. Okay? So here, in these 2 groups here, they are located in y prime, as you see here. They are located in z, and I'm gonna remove x. Okay. For these 2 group here, these 2 here, they are located in x prime. They are located in z, but I'm gonna remove y because this one is y, this one is in y prime. Okay. Again, if you have your group has only 1, it has to be 3 variable. If the group has two squares, it has to be 2 variable. 4 squares should have 1 variable. Yes.
So for this one, it would be actually more simplified with the max term. Because it wraps around, so it's just it would be z prime and x and y.
No, you are telling me this one is more simplified than max terms.
Yeah, wouldn't it be? Because of zeros. If you're just doing the zeros. it would be more
Okay, that's a
simplified.
very good point. Okay. I didn't say now what I'm explaining right now, how can you use maps to calculate the function in sum of product. That's why I'm focusing on ones. We're not working on zeros. You got what I'm saying? I'm not making groups of zeros. Okay. In next section, I'm gonna explain if you have the map, how can you get the format of a product of sum. But now I'm focusing only on sum of products. That's why I'm gonna work on ones in this specific case. When I come to product of sum, I will explain how can we do it. Okay, so now focus only on sum of products. That means I have to work on ones. Let's have again one more example. I have too many examples actually. Okay, anyway, so here I'm telling you 2, 3, 4, 5. So here is 2, 3, 4, 5. So now I put 1 here. Okay, so is that I'm gonna take these 2 together, and then I'm gonna take these 2 together. Do anyone has any suggestion to make something better than that? Can I make it better? Can I make it bigger? No, I don't think I can do anything else, right? So here I'm gonna take this one as a group, and this one is in the area of y, and the area of x prime. These two here are in the area of y prime and x. Okay, so two things here important. That's number one, how can you make groups? Number two, once you make groups, how can you convert this group into a term? Okay? Any question here? Okay. Again, so let's look at this one here, guys. I give you the function this way. You can see here, everyone here is three variables. That min term. Is that okay? So in order, number one, you need to locate these ones here. You need to put them here. In order to put them here, as I explained multiple times, you have two ways. This one means you can do this way. When you look at this one, the intersection of the area of x prime, y prime, z prime, both ones. So here, this is x prime, this is y prime, and this is z prime. Z prime is actually this one and this one. If you look at the intersection of all of them, you will find only this term. This is good. And it has to be only one square because it has three values. This is one way to convert this function into map. There's another way because this one is already three terms. There are three terms. So I can get the main terms. Already this one are main terms. Okay. So here this one 0, 0, 0, which means m is 0. This one is 0, 0, 1, which means 1, and so on. Okay. So whatever. For sure, you can do something. You can do this one if it is two terms or one term. Okay. So again, I think that the easiest way to is just look at the intersection. Okay. So here, because of this one here, I'm gonna put this one. This one is actually the intersection of x prime. X prime is this area here. Y prime is this area. So now we are here, and then z. So this one actually will come to here. Okay. I'm gonna leave the other ones for you. So once I put all ones here, okay, but again, look how many times I repeated, guys. Very simple. Because this term has three variables. So this one should be mapped to only one square. One square. Okay. If it has two terms, so it should be mapped to two squares. Okay. So anyway, so once I have something like that, okay, that's easy. I can take all this group together. Yeah, I can take all this group together to make it y prime. Okay, guys. Now I want you to see the beauty of maps comparing to algebra manipulation. Look at the maps. I just look at the map. Okay, I'm gonna take this one together. It's y prime. It took 0 seconds, right? But if I give you this one and ask you to do algebra manipulation, yes, you will get the same answer, but it's more difficult for sure. But this one, because it's visual, yeah, this one takes them together, it's y prime. You got what I'm saying? Yes, but doesn't mean you should not know algebra manipulation. No, you need to learn algebra manipulation. Okay, I will test you in algebra manipulation, but for sure, most of the time when we do simplification, we use maps because it's much easier. Okay, let's look at example number 8. So yeah, I have one here and one here, one here. Okay, so remember these are neighbors, so I can make only one group. Okay, guys, this way. Why? Because if you roll it, this rule becomes next to each other. Okay, for sure, someone can take these two together and these two together. Okay, but it's not the most simplified. Okay, so most simplified, so you need to take these two and these two, and this area actually is Z prime because it's 4 squares. The group has 4 squares, should have only one variable. Let's see the next one here. Okay, so here I'm gonna put ones in the location of 0, 2, 4, 5, 6. So 0 and 2 and 4, 5 and 6. Right? Yeah. So now we need to cover all these ones. Okay, guys. I want you honestly. Okay, the worst way to study this topic, in my opinion, the worst way is just to see the answer. If you just see the, oh yes, it's easy. This one, that's easy. You got what I'm saying? But if I don't solve it, give it to you, the situation will be completely different. You understand what I'm saying? So if you just read the answer, it looks okay. Okay. So my advice to you, if you want to learn well in this course, you need to you can somehow put it without, to look at the solution, you can, and you have also Zybox as well, but for these examples, try to take this example and solve them without looking into the solution. That's my advice, okay? Anyway, so here again, I have these ones. For sure, one option I have, I can take this 4. Always, I like 4 for sure, to try to look for a group of 4s. Okay, so here I'm gonna take these 4 together. And now after I take these 4, I need to cover these ones. Again, you must cover all ones. If you forget only one, your function is incorrect. So you need to cover all ones. So to cover this one here, I can take it alone, or I can take it with the neighbor. Yeah, for sure, it's much better to take it with the neighbor. Okay. Any question here? Again, 2 things. How to make groups. Number 2, how can you convert, or how can you write the term equivalent to each group, intersection. Okay. So if you look at this part here, because it's 4, should be only one variable, the area of Z prime. But for these 2 here, it should have 2 variables. Okay. So these 2 actually, if you look at, I'm repeating them multiple times, but just in case. So here, this group here, okay, the red group. This one here, it is in X, so I'm gonna take X. It is in Y prime, so I'm gonna put it by Y prime. I'm gonna remove Z because half of it in Z, the other half is Z prime. So I'm gonna take it, remove Z, okay? In other words, if you see the intersection of X and Y prime, you will find this is the intersection of X and Y prime. Any questions? Okay. So now it's almost everything, but here I'm gonna use ABC instead of XYZ, okay? So here I'm using A, the first one, whatever you have in the first one here, whatever it is, okay? So it has to be here. Second one, it has to be here. So when I say X, I'm gonna use X. When I say A, it has to be here, okay? So the third one has to be here, okay? And in the truth table, this one has to be the most significant bit. If you switch it, everything wrong. Okay, so here in the truth table, when I say ABC, okay, so this one I should have 4 zeros, 4 ones. This one is the most significant bit. This one is the least significant bit. Okay? Very important. The order here is very important. Anyway, so let's do this one here, guys. Let's do, for example, here A prime C. Okay. Again, I know this one should be 2 squares. Makes sense? Because it's 2 variables. Okay. So this is the intersection of the area of A prime. This is A prime and C. Okay. So actually, so this one gives you this one and also gives you this one. Okay. So this term is going to give you this 1 and 1. Okay. Let's look at the second term here. A prime B. A prime B. Again, I know this should be 2 ones. A prime. This is A prime. And this is B, right? So this one should give you this one and this one. Okay. Look at the next one here. I know this should be only 1, okay? This is the area of A. This is the area of A, the area of B, and the area of, the area of B prime, which is here, and the area of C. C is here. So if you see the intersection, it becomes only this one. Okay. Any questions? Okay. BC, I know this one should be 2 squares. Okay, B and C. This is B and this is C. So the intersection is here. Okay. Anyway, so now after I map it this way, I need to think about groups. Okay. So here I can take these 4 together as one group. Okay. And for sure, for this one, yeah, this is the best option here. I can take it with the neighbor. Don't take it alone. I'm gonna take it with the neighbor. Okay. Any question? I'm gonna say it again, guys. I know sometimes I repeat. Some students like that, but again, if you look, the worst thing you can do to study this topic is just by looking at the solution. When you look at the solution, it looks easy. But when I give you a question to solve, you are gonna make some you make a lot of mistakes. Okay, so you may forget to, or you may not observe that these are 2 together. You may make one here, or whatever, one here. So you can, okay. So my advice to you is you have 14. I can't make more than that. So I have 14 examples, okay? If you listen to me, when you go home, just take this one, okay? Solve, don't look at this one. Solve it, and then to see how your solution is different, okay? And then you can find what mistakes you make, okay? I just also want to bring to your attention, sometimes there are more than one valid solution. Here, I don't think we can make more than one valid solution in this case, but in some cases, as you will see, I think in one example, you can make more than one valid solution. Okay? And also, you can notice something like that in case of 4, because in case of 4 variable, I have a bigger map, so I'm going to have more options. So that means you can have more than one correct solution. Okay. So anyway, again, let's look at this one. I'm gonna put ones at 3, 4, 6, 7, as you see here. Let's look at groups. Yeah, for sure. I think the best thing I can do here, I can take these two together. They are neighbors. And then for this one here, someone can say, okay, here you can actually have more than one solution. No, you can't have more than one solution. Maybe someone will, some student gonna take these two together and then take this one alone. So now you have three terms. For sure that's bad because I can do better here. Okay. So so the best thing I can do, I can take these two together this way. By this way, I can cover all ones using only 2 groups. Okay. This group here is located in Y and Z. This group here is located in Z prime, is the area of Z prime, and X. Okay, guys, any questions? Okay, let's have one more here in this one. So here I'm gonna put in 3, 4, 5, 6, 7, as you see here. Okay, so in this case, I think once you find 4, okay, I'm very happy. I can cover all these 4. I can cover all these 4 using only one group, and this group is X. Yeah, so this term is actually gonna cover this 4. Okay, so now I need to think about this little guy here, this one here. What I can do with this one? I can take it alone. Okay, this is not a good idea. Okay, this is not that, but I can take it with the neighbor here. It's okay. Any questions? Yeah, you can add one group, for example, something like that, but this is redundant. I already covered these 2. Why cover them again? Redundant group, okay? Anyway, let's have this example. I think in example 13 and 14, I'm gonna show to you that we can have 2 solutions, and both of them are most simplified, both of them are correct. So you will see right now, okay? For example, here I have ones at 0, 1, 2, 5, 6. So 0, 1, 2, 5, 6. Okay, this one. Okay. So look at the main point here. Main point here, guys. You remember when I told you about prime groups? Prime. So actually, yeah, this one is prime group. This one is prime group because it's the maximum group I can make. This one also is a prime group, but I have also another prime group which can be something like that. So it means for this one, I can cover this one by taking it with this neighbor, or I can take it with this neighbor. So it's also prime group. So in total here, I have 4 prime groups. Okay. Which groups are essential? Which groups are essential? Again, essential means you have 2 solutions, but this group you must take it. This group is essential. Why? Because to cover this one, I have only one solution. That's why I call it essential. So that's why you can find this group you will find here, also you can find here. I have 2 different solutions, but this one is essential. So this one will appear in all solutions. Same thing for this one. To cover this one belongs only to one group. You got what I'm saying? So to cover this one, we have only one option, which is this one. So this group is essential. So in this example, I have 2 essential groups, this one and this one. So that's why you can see them, they are I'm gonna take these 2 groups here in this solution. Also, I'm gonna take them. However, to cover this one here, I have 2 solutions. They are not essential, okay? Because I have options. For this one, I can take it with this one, and also I can take it with this one. and both of them are more simplified. Okay, so here what I can do here, guys. So I'm gonna take this one with this neighbor, okay, and this will make this term here x prime, y prime, or I can take this one with the neighbor here. Also, I'm gonna make this term, okay. So you can see here, guys, in this here, I have two valid solution, okay. If you look at this equation, both of them have three terms, and all terms have two variables. So none of them is better than the other. Any questions? Okay. Same thing, I'm gonna go to the last one here, the last example I have. Okay, guys. So here I'm gonna put ones in this location, 0, 2, 3, 4, 5, 7, as you see here. Okay. And now let's see what groups here again essential. For example, here I have here actually so for example, to cover this one, I have multiple options, for example. Okay, to cover this one, I can take these two together, right? So this is also another option. Okay, to cover this one here, so I have this option as well here. You got what I'm saying? So either to cover this one, either I take it with this neighbor or this neighbor. Okay. To cover this one, I can to cover this one here, either I take it with this neighbor or with this neighbor. Okay. So it looks like in this very very interesting example, it looks like we don't have any essential groups. So because this one it's in two groups and no one is better than the other. So I can take this group or that group. Same thing. So it looks like every one of them I have multiple options here. So you can look here, guys, again. Can I make a group of 4? No, I can't make a group of 4. Okay, here. The big thing I can just take two and two. Okay. So one solution, I can take these two together. I can take these two together, and I can take these two together. This is one solution. Another solution, I can, which by the way, in this example, you can have 3 or 4 different solutions, and all of them are correct, by the way, in this example. Okay. So one way, another way, I can take these two together like this way, and then I'm gonna take this, or I can take also these two together, and I can take this together. Still, I can cover, and I think that's what I did here. You can find more solutions, okay? Because you have variation, you have different options. You got what I'm saying? So, for example, if I want to cover this one, I can take it with this neighbor, or I can take it with this neighbor. This one option. If I want to cover this one here, I can take it with this neighbor or with this neighbor. Okay. So again, you can. Any questions? Okay. So I think I don't have much time, but I can just start talking about it. We still have 3 minutes. Okay. So here, in case of 4 variables, nothing is new. Nothing. I'm gonna repeat everything again. Number one, similar to what I did here. Number one, I need to choose the map. But for sure now the map is bigger. Why? Because there is a relation, as I told you before, number of squares and number of variables. The relation is 2 to the power of n. Because I have 4 variables, that means I'm going to have 16, 2 to the power of 4. We're going to have, so this map is going to be double this map. You can think now, why, you can imagine why we usually stop at 4 variables. Because if you think about 5 variables, so every time you increase the variable by 1, you double the number of squares. Okay, so it's going to be 32 squares. It's going to be very difficult to find groups. Okay, best option or best groups by yourself, because the map is going to be very big. Okay, so again, what I'm going to do is number one, I will choose a map. Okay, for 4 variables. It's exactly the same thing. The intersection of the regions. It's the same thing. You need to know where are the location of the main terms. Almost it's the same thing. If you give your function this way, how can you put ones? How can you map it to ones? Almost the same thing as I explained here. Number 2, also I'm going to talk about neighbors. Who are the neighbors? Here, in case of 3 variables, every square has 3 neighbors. But in case of 4 variables, every square has 4 neighbors. You got what I'm saying? So it's almost everything is the same. Here, either you make group of 1s or 2 or 4 or 8. But in case of, for sure, we don't, it is very extreme case, okay? But in case of, for variable, you can make group of 1, you can make group of 2, you can make group of 4, or also you can make group of 8. For sure, 16 is a very extreme example. 16 means all of them are ones. This happens only in case f equal to 1. If you have functions that always give you 1, so I'm going to put 1 on all squares. Okay? So anyway, so this is very extreme case. So that's why now I can make group of 1, 2, 4, and 8. So just I'm going to show you what I'm going to explain is just it's very related to what I did here. Also, same thing. You need to also make groups. Once you make groups, and then we need to cover all ones. Same thing. You need to cover all ones. You need to minimize the number of groups, maximize the size of groups. Okay. Okay, guys. So next time I will start explaining for them. I told you the test one. It will be on March 7th. Okay. I will send you an email about what topic exactly you need to study. On Thursday, a couple of Thursday, I will give you a quiz. This quiz should cover. I will the variable map. So I will give you a function similar to the example you have here. I will give you a function, then I will ask you to make the map, okay, and simplify it. Okay. When I give you a function, I can give you a function in any of the format I explained. Okay, guys? Thanks.